like you guys may know or may not know, depending on how much you've heard from me or if you saw my webinar yesterday, my presentation is about the acoustic attenuation of common face masks. And I know I didn't have a lot of time yesterday with Deaf Ed Ohio, so if any of you guys are joining me from there, I'm sorry, but I just wanted to introduce myself and kind of lay a groundwork for who I am. To start, I'm a high school senior at Hilliard-Davidson, and I myself have moderate bilateral hearing loss, so I wear hearing aids in both ears. Kind of a fun fact, I am a beekeeper of 60,000 bees. It's a lot of bees. And I am 1/6 of the Phonactine Advisory Board. And you've got to kind of sit and think and be like, okay, why did she choose this? And there was a day that I was donating blood at the Red Cross, and I realized that I couldn't understand the nurses well when they were wearing their mask. So this kind of gave me this question of, what if different masks have different sound qualities? Wouldn't it be really cool to know that? Like, and very helpful as well. So that's how I came up with this idea for my project. So some general things that you should probably know. First of all, what the heck is acoustic attenuation? Acoustic attenuation is the decibel loss at a particular frequency. So you can think of this kind of like an audiogram, or like with hearing loss on it, where you have a certain like point in the frequency graph where you don't hear as well due to there being just less sound there. And this is what I used and I defined by how I like establish which masks have the best versus worst audio quality. In general, the closer the number is to 0 decibels, the less attenuation there is. Anything that's higher or more positive, if you think of it that way, the more attenuation there is. Any negative numbers, and you'll see them, and I will explain it, indicate vibration resonance, which is actually kind of cool. It's a cool concept to think about, but just something to keep in mind. Anything, if you're not familiar with frequencies, anything closer to 0 hertz is really low frequency. Anything that's closer to 12 kilohertz is really high pitched. I use 2 different types of graphs. One of them is a standard line graph. The other one is a spectrogram. And this displays a relative signal strength during a particular time in the audio. So is the volume here particularly loud, or is it just kind of quiet? And you can see the difference in it, and I use that through Audacity. I normalize the control to the x-axis, meaning that you won't see a line with the control. Rather, the control is the x-axis. So if it is above the line, the x-axis, or below the x-axis, that's the deviation from the control. All graphs, except for one, which I establish, is on a horizontal logarithmic scale to make it more legible to any audiologists who may be watching. So this idea of vibration resonance, which I feel like I should explain before I get into this, is this phenomena where the material is subject to a sound or a vibration and produces a louder sound. It's called a resonant frequency, where it kind of hits this perfect frequency and it actually amplifies it. So you can kind of think of this as a guitar, where it goes in and it's kind of loud and it comes out louder. But this is still bad. It doesn't make it better because there's more sound. It's bad because it masks any other frequencies. And this, I noticed, mainly occurs on anything with a hard surface. So again, just kind of keep that in mind, where it's not necessarily good, but it's just something to think about. Some of you guys might be familiar with the speech banana. This is it's kind of like an audiogram where it shows the relative decibel intensity and frequency where most English sounds happen. So, for example, the ling 6 sounds, the u, I, ish, like those sounds, are all somewhere on this speech banana. And for example, you're really going to want to watch out for anything between 200 and 300 hertz, where you have 3 of the 6 ling sounds. Anything between 700 and 800 hertz, anything around 2500 hertz, and anything around 5000 hertz. All of this is indicative of most of the sounds in the English language and kind of blanket covers stuff that you should be aware of. In general, spoken English typically ranges from 150 hertz to 10 kilohertz, and this is also demonstrated by my audiobook recording. But I decided to do above and below that just to make sure that I accounted for anything that might be within those boundaries. For my experimental setup itself, I used a foam head with a Sony SRX XB01 Bluetooth speaker. This Bluetooth speaker accompanied all of my specifications that I needed, and it also covered the frequency range that I needed, which was very hard to find in a very small speaker. I also used for my microphone, which I am actually using right now, a Becaster microphone in cardioid and mono mode. Cardioid meaning that it is unidirectional and it only takes sound from one place. This would reduce the impact of any echoes on my results. And mono meaning one track, so I only had to deal with one track instead of two. I placed my tables 6 feet apart in a sound booth and covered them with fabric, again, to avoid echoes that might impact my results. In terms of what masks I tested, this is my lovely mask slide. These are all of the masks that I tested, mask combinations, and they're modeled by my mannequin. I tried to group everything by kind of the category it fit into. For example, for the N95, KN95, and the N95 in the face shield, all of those have to do with like personal safety versus fabric masks or disposable, like the surgical masks. So this is kind of the baseline I should set for what I call all of my masks. Keep in mind there is a difference between the Clearview fabric mask and the clear mask. Those are fairly easy to get mixed up, but please note they are two different masks. I ran 2 tests. The first is a pure tone test. I started at 100 hertz, increased by 100 hertz until 1,000, and from 1,000, I increased by 500 hertz until I reached 12 kilohertz, so 12,000 hertz. The other test I ran, which you will see later, is called an audiobook sample test, and I ran a sample from The Masque of the Red Death by Edgar Allan Poe. I thought that it was a little bit funny, but I ran a 2-minute sample from that to kind of help emulate what real spoken English would look like. So this is the pure tone test. And this is the spectrogram I was talking about earlier. This is through Audacity, and I kind of highlighted the frequencies that you should care about between the 2 red bars, where they're pretty much the majority of spoken English takes place. You can notice, especially on the masks down here, on the N95, the face shield, and the fabric Clearview mask, there's a lot of attenuation or like a lower signal strength in higher frequencies. And this is a little bit concerning, as you will see throughout the presentation, where most of the high frequencies indicate the clarity of language. For example, making the difference between dog and dogs, that sound is at 5,000 hertz. So you've got to make sure that you have that high-pitched sound. So that's just kind of the real-world application of what my results are. If it's a higher frequency and you're losing the higher frequencies, you're going to lose a lot of that clarity. This is a little bit different. It's a frequency plot spectrum graph. And again, this is kind of a vertical way to show the relative signal strength. You can notice, especially in the N95 face shield and Clearview mask, like I pointed out earlier, that you attenuate and you lose a lot of that signal for the high frequencies. Pretty much anything between 1,000 hertz and 10,000 hertz attenuates a lot. So in terms of interests and kind of a general blanket graph of my results, this is what I would call my high interest mask, where these are the most frequent masks that I see applied in a situation with a deaf and hard of hearing person, or just used generally around in the public. So we have the disposable surgical mask, accordion fabric mask, Clearview fabric mask, face shield, and N95. Just looking at this right out the door, I can let you know that the Clearview fabric mask and the face shield attenuate the worst, The N95 is about in the middle. I mean, all of this is relative, I should say that. All of my graph results are relative. So if I say, oh, the N95 is the worst here, and then I show another graph and I say, oh, but it's the best here, it's not the worst or the best. That's just how it compares with those other masks. So in this case, the N95 is in the middle of all of them. And then you have the surgical mask and the accordion fabric mask are about the same, but the surgical mask is a little bit better. And while I was doing my testing, I was kind of wondering, like, okay, what would happen if you were to layer them? In some hospitals and healthcare settings, they have to layer the mask. So I was like, okay, is it like, would you have the same difference? Would you have a different constant? Like, how would they vary? And what I found is that they ultimately just about vary by the same constant. So if you look between the difference of the masks between one surgical mask and two surgical masks, it's about the same as the difference between two surgical masks and three surgical masks. There's a little bit like a smaller difference between the two surgical masks and the three surgical masks. Like that jump is a little bit smaller, but ultimately they're about the same. They about mirror each other. I thought this was really interesting because if you think about the physics of it, the sound wave is hitting multiple like barriers before it's getting out and recorded by the microphone. So they just about varied by the same constant, which is kind of interesting to see. In terms of personal safety, I tested an N95, KN95, a face shield with an N95, and then a furnace filter hospital fabric mask. And kind of the furnace filter hospital fabric mask, I think I should lay a little bit of foundation for that. It is a fabric mask with a filter in it that effectively mimics an N95. So it is effectively a reusable N95 if you think about it that way. And among all of these, I think there's a pretty clear indicator of which one attenuates the worst. The face shield and the N95 together, pretty much the two worst masks that have the worst attenuation, attenuated the most. Who knew? This was kind of, again, something that you would use in a hospital setting maybe, and that's very bad for audio quality. I mean, coming next, I would probably say the N95 is the worst, followed by the furnace filter hospital mask, and then the KN95 is the best. Again, all of this is relative, as you will pretty soon see. After this, I was thinking about, okay, what about sustainability? What about wearing a fabric mask and using that? And ultimately, we found that the Clearview fabric mask, like the ones that Ohio Hands and Voices made for their fundraiser, those attenuate really bad. And this kind of begins to beg the question of, okay, where do you draw the line between the visual access and the sound access? Because you will find that they are not mutually inclusive. In the other results, the accordion style fabric mask is probably the next one, followed by the furnace filter hospital mask. And then actually, this is interesting because there is such a difference between the accordion style mask and the shape style fabric mask that it's actually better to wear the shape style fabric mask in terms of attenuation. The same number, like layers of fabric, same number of threads per inch, all of that. And we think that this is because of the pleats in the accordion style fabric mask, where the sound kind of hits the pleats and they kind of have to bounce back and forth before coming out. It's just another thing that prevents it from coming out, and therefore it attenuates a little bit worse. Again, I thought this was very interesting that the style of mask that you wear actually impacts your sound quality. I was very lucky to collaborate with some of the Dublin students. They are Dublin Kaufman students. They're from the FRC Team 1014, and their district deaf ed specialist contacted them at the beginning of the pandemic and said, hey, we've got this problem. What about the deaf students? Like in our classrooms, we kind of need visual access for them. And they took that and they came back with a solution. So it is effectively a face shield with fabric on the bottom and sides to give a little bit more protection to the wearer as well as anybody else around them. So more protection in theory than a face shield, like a regular one, but it still provides the visual access that you would need. And actually the coolest part about this is that Dublin is implementing these in their classrooms by the request of the teacher. So any teacher working with a deaf student can request this, or any teacher in general can request it and receive it to work with in the classroom, which I think is really cool. Once again, this is the spectrogram comparison. You'll see that you lose a lot of signal strength in like all of this. So once again, you've kind of got to keep in mind anything that's like over here and like even in the middle to high frequencies are the most important to hearing, like clarity and conversation and just spoken English in general. So just kind of keep that in mind when you look at the results. They're not, it's really disappointing, but it's not as good as any of the other masks that I tested. I recognize this is a little bit crammed in, so I separated them on the next slide. But you should notice like the graph goes up to 40 decibels in terms of attenuation. You can kind of think about that as like 40 decibels of hearing loss at that point. Like anywhere where it, like again, read it like an audiogram where it's, you see that number and it's like, okay, you have 40 decibels of hearing loss at 100 hertz or 1,000 hertz. So I've just kind of used that as my scale of think about it like hearing loss, because a lot of you are familiar with hearing loss and audiograms in some way, shape, or form, or one or another. In terms of a mask style, this is a comparison between the Clearview fabric mask and the clear mask. It's really hard to differentiate between which one would be better. I would say that the Clearview fabric mask would be a little bit better, mostly because anything after 10,000 hertz is not replicatable by the voice. And the clear mask is also not reusable. You kind of use it once and then you're done. In terms of the face shield, I would say that the engineering face shield unfortunately attenuates worse, but actually not that much worse. As you'll see on the next slide, I set up a comparison for what it would be like to compare this engineering face shield with, like, for example, a disposable surgical mask and a face shield, a combination. This is because they're in the Dublin School District. This is what they're leaning towards. Okay, have the teacher in a face shield and a mask in order to protect the students in a better way. So, oh, maybe I didn't. I think it's at the end of the presentation, but you'll see it then too, where it's actually a little bit worse on the face shield plus a fabric mask, to the point that I would recommend, based on my results, that teachers who are instructing deaf students wear the engineering face mask so that you still have the visibility. Okay, and onto the audiobook test. I tested this in increments of 100 hertz, so I just kind of threw it all in Excel and like shuffled it out to 100 hertz blocks effectively. So it's there's a lot more data points in this, but it replicates English a little bit better. This is the plot spectrum graph again, where you see that pretty much anything after 4,000 hertz is lost until you get up to about 10,000 hertz. So once again, this is a little bit concerning because a lot of your higher frequencies and like plurals and all of those sounds happen in that area. This follows the same style as before, where I do the like most interests and then all of the other ones. So this is, once again, the face shield, N95 Clearview fabric mask, accordion style fabric mask, and then the disposable surgical mask. I think it's pretty clear here as well which ones are the worst and which ones are the best. In terms of the worst, once again, you're looking at the face shield and the Clearview fabric mask. In the middle, you have the N95, and then the best ones you have are the surgical mask and the accordion style fabric mask. Once again, with layering, you can see that there is about the same constant difference. There's a little bit of a bigger gap between between 1,000 and 5,000, and then 5,000 and 10,000. It's a little bit bigger of a gap, but it's not that much actually. So once again, you're kind of varying by a constant. So if you put on one mask and say it attenuates 5 decibels at a certain frequency, you put on 2 surgical masks, it attenuates about 10 decibels. And you put on 3 surgical masks, it attenuates 15 decibels. That's just kind of a random number to give you an idea of what I mean by saying like a constant. For the N95 and N95 equivalents, once again, you're looking at really bad attenuation with the face shield and N95. Just a reminder that anything below the x-axis, because it deviates from the control and it's also a vibration thing, it's actually still acting like attenuation because it is masking other frequencies. So just kind of keep that in mind, because even though the face shield and N95 looks like it's better because it goes negative, it's not actually better. So that is the face shield and N95. Next, I would say the N95, followed by the probably the furnace filter hospital mask, actually, or the KN95. It honestly depends on maybe if you're male or female. Like, it depends on your voice quality at that point. You can see that the KN95 is better between 1,000 and 5,000 hertz, whereas the furnace filter hospital fabric mask is better between 5,000 and 10,000 hertz. So just kind of something to keep in mind of these results don't just end at, okay, here's my flat out results. No, it also depends on like your voice, like depth, I guess is the best way to say it. Once again, looking at fabric masks, we have the Clearview fabric mask at the worst. Again, no surprise there. Probably the runner-up next would be the furnace filter hospital mask, followed by the accordion style fabric mask, and then the shaped style fabric mask. This kind of goes back to the whole the pleats versus the smooth shape, and that kind of makes a pretty big difference. Once again, with the visual solutions, if you want to talk about crammed, this is crammed. Yeah, again, I separated them on the next slide where you can see it a little bit better. So once again, looking at these results, these are the same results that I showed yesterday with the other audiobook results. I would say in this case that the Clearview face mask, when compared with the clear mask, is actually better. Again, this is kind of a play it by ear, what tone, what depths does your voice have? If your voice is deeper, you might want to stay with a clear mask, or if your voice is a little bit higher pitched, you might want to stay with a Clearview, or vice versa. Like, it really depends on what you need and what your students need as well. In terms of visual access, they're about the same between the face shield and the engineered face shield as well. This is the comparison graph that I was talking about earlier. This is the one graph that is not on a logarithmic scale. I did this so you can see the middle frequencies a little bit better, so it's not so like crammed in with each other. You can see here that it's again kind of varying by a constant, but the surgical mask and the face shield attenuates worse than the engineering face shield does. And it takes away the visual component. So again, in this case, if I was basing any opinion off of my results, I would say that using a face shield with fabric or something similar on it would be better than pairing up a mask with a face shield. So, in conclusion, unfortunately, and of course I'm not happy about it either because I use visual access for a lot of things, it seems that there is a lot of attenuation with visual access solutions as opposed to non-visual access solutions. So anything with a hard surface on it attenuates really bad. In terms of acoustic attenuation, if you really want the best sound quality, I would go with a disposable surgical mask. And again, anything with a face shield in particular seemed to attenuate the worst, but anything with visual access didn't do very well either. There's many things to consider though before choosing a mask to use in the classroom or use with your deaf friends or stuff like that, because there's a lot of things to consider. Like there's personal safety, visual access, comfort, environmental impact. All of those things impact what type of mask that you wear. So just kind of keep that in mind, that it is very much kind of a toss-up. You kind of have to experiment a little bit with it. I don't know how many of you guys wanted to see this, but the best versus the worst attenuation, you can see the graph here. It is not on a logarithmic scale either, but you can see where the face shield in N95 very heavily attenuates when compared to the surgical mask. So this is the best versus worst attenuation graph, if you wanted to see that. So this is the part in the presentation where I ask if anybody has any questions. I thought this was kind of a cool graph because it has a lot of colors on it, but yeah. So if anybody has any questions now, please feel free to unmute yourself and I will address them.